we are going to look at some statistical tables and graphs. So this first table represents what's called a group frequency distribution. It is showing us the number of hours students spent on the computer per week for 57 total students. So first, just in reading the table, you'll notice that 5 students out of this particular group spent between 0 and 4.4 hours a week. And then if we come down here, this means that 12 students spent between 13 and a half up to 17.9 hours. Now, this first question asks us what the class width is. And so the way you find your class width is you take the difference between the beginning of a class on one level minus the beginning on another. So you could look right there and you could simply say 4.5 minus 0.0, and you get 4.5. Or you could look, you don't have to look there necessarily. You could look at the end of a class and you take the higher end minus the lower end, and that's also going to tell you your class width. So those should be the same when you're looking from one class to another. So 4.5 is my class width. So we have another frequency distribution, and again it's the number of hours spent on a computer, and there are 50 total students they're telling me here. But this time they're asking me what percentage of students spent between 14 and 17.4 hours. So you have to find what we're talking about in the table, and sometimes it may just be a single class as it is here, or maybe it's a combination of several classes. This is just a single class. We see there are 5 students in that group. Remember, it was out of the total of 50. Now, if I want to, I can reduce that fraction first, but because they're looking for a percentage, I have to actually divide it out. So whether you divide it out by hand or on a calculator, you have to get a decimal. So 1 divided by 10 would be the decimal 0.1. And then the way that we change a decimal to a percentage is we move the decimal 2 places to the right. So when I do that, I'm left with 10%. Now we're looking at a statistical graph. Notice that they're telling us the title is the value of 3 stocks over 7 days. You'll notice over here we have a legend so that we know stock A versus B versus C. They're showing us down here that this represents which day, because we're looking at 7 days. And then over on the left side, we're looking at the price in dollars. And so they're asking us to choose a correct answer. So notice the first answer says a legend is not included. So it's unclear what each line in the graph represents. Well, that's not true because we see right here that we have a legend included. The second answer says your horizontal axis uses an inconsistent scale. Well, this is my horizontal axis here. Notice it goes from day 1 up through day 7. It's scaled by single days. So that's not true. That's not inconsistent. So it's not misrepresenting time between data points. All right, the third answer says just the graph is not misleading. Well, we'll come back to that. Let's see what the other answers say. The fourth answer says the vertical scale is much larger. So now we're looking here at the vertical scale is much larger than the range of values. Well, that's certainly not the case because when you see the data points plotted, they certainly fall within the range of values on that vertical scale. So it's not making it difficult. The last one talks again about the vertical scale. They're saying it's too small, which makes it difficult to locate some data points. And again, when I look at the data points they've plotted, they all seem very clear and seem like they were easy to locate. So this would be an example of a graph that is not misleading, okay? But they could certainly give you one that either was, missing the legend over here, or maybe they didn't have this scale. Maybe they went from 1 to 4 to 8 or something. Or they could have a vertical axis that is either too many data points or not wide enough.